Okay, we're going to find the second derivative, and then we're going to find possible points of inflection and discuss the concavity for number 16. All right, so to avoid the product rule, I'm going to multiply this in. So I have x to the 4th minus 4x to the 3rd. Okay, I'm going to find the first derivative first. So I get 4x to the 3rd minus 12x squared. Okay, second derivative, I get 12x squared minus 24x. Okay, I'm going to set the second derivative equal to 0. Okay, I have a 12x in common. I'm going to take it out. I get x minus 2. So I have two possible points of inflection at 0 and 2. All right, so now I'm going to set up my intervals, 0 and 2. And I'm going to test from negative infinity to 0 in the second derivative, from 0 to 2 in the second derivative, and from 2 to infinity in the second derivative. All right, so second derivative, I'm going to test negative 1 here. So I have 12 times negative 1 squared minus 24 times negative 1. All right, this is a positive 12 and a positive 24, so we got a positive number, which means I'm concave up on this interval. All right, 1. Plugging in 1, I get a negative number, which means I'm concave down. And then here we'll plug in 10. We got 100 times 12 is 1200 minus 240. That's going to be positive, so that's concave up. So I have a change in concavity twice, so I have 2 points of inflection at 0 and 2. So now I go back into the original function, and I'm going to plug in 0. So I'm going to plug it into after I distributed the x to the 3rd. So 0 to the 4th minus 4 times 0 to the 3rd. So my first point of inflection is 0, 0. All right, now I have to plug in 2. So I have 2 to the 4th minus 4 times 2 to the 3rd. All right, we got 16 minus, this is 8 times 4, which is 32. So I have 2, negative 16. So my points of inflection are 0, 0, and 2, negative 16.